So last time we started graphing, and we basically had, a constant raised to the power of x. The only variation from that is we had a negative out front, which gave us the reflection around the x-axis. Today we're going to add to that, right? So this first example, we have 3 times 2 to the x. So again, what do you think this is? Growth or decay? Growth. Okay, so the asymptote is still going to be y equals 0. We haven't learned otherwise yet. The y-intercept, we're still going to plug in x equals 0. So f of 0 is 3 times 2 to the 0, which is 3 times 1, which is 3. Okay? So you can write that as, the y-intercept is y equals 3, or you could even write that as 0, 3 for the y-intercept. X is 0, y is 3. So since it's growth, I'm, picking x values from -1 to 2. So here I have 3 times 2 to the -1, and that will be 3 times 2 to the -1. Remember, it'll be a reciprocal. So 2 will become 1 over 2 to the 1. So that will be 3 over 2. And then I just did this. 3 times 2 to the 0 is 3, we said. 3 times 2 to the 1 is 6. 3 times 2 to the 2 is 4 times 3, 12. Okay? All right. So domain was what for these? All real numbers. So the range, remember, it has to be y, and it has to be compared to the horizontal asymptote, which is 0. So now we just have to decide if this is greater than 0 or less than 0. If we go back to the original function, you notice, right, 3 times 2 to the power of x, the coefficient, right, at the very front is positive, right? We have a positive 3, not a negative 3. And we said last time, if it's positive, would it be greater than or less than the asymptote? Correct, greater than. Okay? All right, so let's see if when we draw the graph, that's going to confirm all that. So here we go. Here's the graph. All right, so so at -1, y is 3 over 2, which is 1.5. 0, 3. 1, 6. And then the next point, x equals 2, y equals 12, that's going to go off my grid. But do you see how I already have 3 points? 3 points, that's the minimum. If you have 3 and the fourth one is going to go off the grid, you won't have to draw it. So these are good enough, and it looks just like before. And yes, we were correct in the range and all that good stuff. Okay, so now I have f of x equals -3 times 3 to the x. Asymptote is what again? Y equals 0. Y-intercept, -3 times 3 to the 0. -3 times 1, -3. Right. So again, growth. So -3 times 3 to the -1 is -3 times. So 3 to the -1, right? If it's a negative exponent, the 3 will become its reciprocal, 1 over 3 to the 1. So that would be -1. All right, so I'll give you a few seconds to please fill in the other ones and do the domain and range, right? Fill in the table and do the domain and range. Here we do have, the numbers going from -1 to -27. Range is y is less than 0. And if I graphed this, everything will be confirmed. So at -1, y is -1, 0, -3, 1, -9. And then it goes down to -27, which again, I don't have to draw. So when I connect these, that's what that looks like. Okay? All right, so let's talk about these two for a minute. Let's revisit these. Both of these were growth, right? So let's take a look. When you go towards the right, does the graph for the top one go towards or away from the x-axis? Huh? Away from, right? Which is decay. I mean, which is growth. Exactly. So here too, graph goes away, so it's growth. Okay. So next. Now take a look at this. We have -5, we have f of x equals 5 to the power of, not x anymore, it's now 5 to the power of x minus 2. The exponent is now changed to x minus 2, right? When you have that, when you have a number added to or subtracted from the x, this is a horizontal change, right? A horizontal shift. So what do? How do we figure out how to change it? Look up here, everyone. You take the x minus 2, set it equal to 0, and solve. So x becomes positive 2. Since it's a positive number, we say the graph is shifted to the right by 2 units. Positive 2 means right 2. Negative 2 would have been where? Left 2. Okay, so now let's graph this one. Asymptote is y equals 0 again, until I tell you otherwise. Okay, y-intercept. 5 to the power of 0 minus 2 is 5 to the power of -2. So again, negative exponent means take the 5 and make it into a reciprocal. So 5 becomes 1 over 5 to the power of 2, 1 over 25. Okay? Yep.
Why aren't we doing the f?
You can write it either way. I just eliminated it here because there was like too many steps anyway. You can write it. F of 0 equals that. Okay? Okay. So so this is growth again. So this is the numbers I have. But look, this is a good example of where sometimes these numbers, -1 to 2, might not necessarily be the right choice of number. Okay? What do I mean by that? Let's take a look at the first one. 5 times -1 minus 2. I'm sorry, 5 to the power of -3. Negative exponent means make the 5 a reciprocal. 1 over 5 to the power of 3. Okay, that is not a good number because that is 1 over 125. Can you even graph that? No. So that number is too small. Not a good number, so I'm just going to not use it. Okay? When x is 0, I just, did that one. I got 1 over 25. Okay, I'm not crazy about that number too, but whatever. It's the y-intercept. That's an important point. Let's do the next one. 5 to the 1 minus 2. 5 to the minus 1. 1 over 5. 5 to the 2 of, when x is 2, 5 to the 2 minus 2. 5 to the 0, I get 1. Okay, so take a look at these numbers. Let's just graph this. Y equals 0. Okay? My first number, okay, I have 0, 1 over 25. Okay, whatever. Then 1 over 5. That's right there. Like, yeah, you can't even graph the difference there. Then I'm at 1. Yeah, I have 3 numbers here, but these are they're too tiny for me to be able to get like a good graph, right? So what I do in this case, you see how like this was not a good one to use with the -1? You can just add another number here, like 3. So I get 5 to the 3 minus 2, which is 5 to the 1, which is 5. So that's what I mean when I say you can modify that list as it suits you, right? So now, okay, that's a little bit better for me to be able to graph. Okay, do you guys see what I'm talking about? So, okay, I think we're experts at the domain and range now. Okay? All right, let's move on. All right, one more. Next one. Next I have 1 over 3 to the x minus 3. So right up to 1 over 3 to the x, this is exactly like what we've been seeing until now. The change now is there is a minus 3 here, but that minus 3 hasn't been applied to the x. It's done to the whole graph, right? You guys with me? That term, negative 3, that has a different function. It makes a vertical shift to the graph. This time though, whatever that number is, that is the direction in which the graph moves. So if it's minus 3, the graph shifts down 3 units. Okay? Oh, I can't see that. There you go, sorry. So the graph shifts down 3 units. But now guys, look. If I were to shift this graph down 3 units, the graph is attached to the asymptote. So the asymptote will also switch down 3 units. Okay? Nisan, you with me? So the new asymptote here will be y equals negative 3. Okay, so let's graph that one. So I have blah, blah, blah to the x minus 3. Asymptote, y equals negative 3. It's exactly that number. The y-intercept, same situation. 1 over 3 to the 0 minus 3. 1 minus 3, negative 2. Okay, so technically this is decay, so I did pick these numbers for this one. Let's go ahead and do this. 1 over 3.
Wait, is decay?
It is decay because the number raised to the exponent is right. So 1 over 3 to the negative 2 minus 3. So take a look at what happens here. You have a negative exponent that belongs to the 1/3. You take the 1/3 and you have to take the reciprocal. So 3 to the 2 minus 3. That becomes 6. Okay, I'm going to give you like 3 to 4 seconds to do the other ones. Negative 1, 0, 1. Okay, or maybe 20 seconds. Go. Right, so what we get is, 0, 2. This last one, 1 over 3 minus 3 is 1 over 3 minus 9 over 3, which is negative 8 over 3. Right, so what is the, I kind of want to do the range before I even draw it, right? So what have we always been saying about the range? It's y compared to the asymptote. What's the asymptote in this case? Negative 3. So now go over here, right? So negative 3, that's the same number. Now, go over here. Is that a positive or a negative coefficient? Positive, making this greater than negative 3. So now let's see if we did that correctly. Let's actually graph the asymptote. Y equals negative 3. And let's put our points. At negative 2, y is 6. Negative 1, y is 0. 0, y is negative 2. 1, negative 8 over 3 is negative 2 and 2/3. So right over there. And when I graph, there. Okay? Fabulous. All right, so that much for today, and you have the second handout, right? Okay.